radical functions. And when I say a radical function, that's going to be any function that involves a square root or a cubed root or any root for that matter. So it could be the fourth root or the fifth root, anything that has a square root or a radical is going to be a radical function. Now, we're going to start by talking about the inverse of a quadratic function. So in this case, we've got f of x equals x minus 2 squared minus 3. When we deal with the inverse of a quadratic, we need to restrict the domain of that quadratic so that it's 1-to-1. And the reason for that is because if you just have, let's go ahead and graph this, the -3 is going to move it down 3, and the -2 inside is actually going to shift it right 2. Remember, it does the opposite of what you think. So our vertex is going to be right here, and then it's not stretched any, so it's just going to be the same width as your parent function. So it'll look about like this sketch right here. That's our f of x. When you take the inverse, graphically what that means is you're reflecting across the line y equals x. Algebraically, what you're doing is switching your domain and range. But if you look at the graph, if we flip that over the graph, it's going to be somewhere around here. Well, that is not a function. So what we need to do is restrict it to 1/2 of the parabola. We can do the positive side or the negative side. I'm going to choose this side, which is going to split it right down the middle or the axis of symmetry at x equals 2. So we're going to restrict this domain to x is greater than or equal to 2, so that when we flip that, we still get a function. So now let's look at the function f of x of our quadratic. First of all, I'm going to change that y, the f of x to y. And then to take the inverse, you switch your domain and range. So I'm going to change my y to an x and my x to a y. And then I'm going to solve for y. So I'm going to add 3 to both sides. So I've got x plus 3 equals y minus 2 squared. Now if I want to get rid of that squared, I need to square root both sides, which will leave me, remember when you square root both sides, you get positive or negative square root of x plus 3 equals, and then on the right, the square root undoes the square, so you're just left with what's under it, which is y minus 2. And then I'm almost done. I'm just going to add 2 to both sides. So that gives me positive or negative square root of x plus 3 plus 2 equals y. Now, because I restricted my domain, I'm only using the positive value instead of the negative. So my inverse, f inverse of x, is going to equal the positive square root of x plus 3 plus 2. So if I graph that, that's going to be up 2 and then shifted to the left 3. So it'll be 1, 2, 3 there. And it'll look like a half of a parabola, something like that. So if you can visualize flipping what I have highlighted in pink over this line, it will give you our new inverse function. So that is the inverse of our quadratic after you've restricted the domain. So let's look at the next example. We've got to find the inverse of f of x equals 5x cubed plus 1. We're going to do the same thing. We're going to switch our domain and range. So if I have y equals 5x cubed plus 1, I'm going to make all my y's x's and all my x's y's, and then solve for y. So I've got to subtract 1 from both sides. So I've got x minus 1 equals 5y. I'm sorry, that's a cubed. And then I'm going to divide by 5. And that'll leave me y cubed equals x minus 1 over 5. And then I'm going to take the cubed root of both sides. And I'm taking the cubed root because my degree is 3. So when I want to undo that, that's just going to leave me y. And then I've got the cubed root of x minus 1 over 5. Now this one you don't have the positive or negative like we did up here. And that is because this is an odd root. And you can have a negative under the square root, or the cubed root, or when you cube something, you can still get a negative. So, and that's with any odd power. If you have a odd root, it's just going to be that answer. You don't get the positive or negative. If your root is an even, like 2, 4, 6, 8, you'll get positive or negative, whatever your answer is. So our final answer here is f inverse of the cubed root of x minus 1 over 5. And that is your inverse function. The entire thing is under the cubed root. Okay, next we've got the domain of radical functions. And just like before when we've dealt with domain, you're going to look for problem spots. So our two problem spots are if our denominator equals 0, or in this case, what we're going to deal with mainly is a negative under the radical or under a square root. So in this first example, we've got x minus 4 is under the square root. It needs to be positive, so we're going to say it's greater than or equal to 0. And then you just solve that normally, and you end up with x is greater than or equal to 4. So your domain has to be greater than or equal to 4, or in interval notation, you're going to have a bracket on 4 because you can include 4 to infinity. On the next example, when you look for the problem spots, there's a couple problem spots. First of all, you've got a fraction, so what's under there cannot equal 0. So x minus 1 cannot equal 0. So when I add 1 to both sides, I end up with x cannot equal 1. So that's one problem spot. And then also the whole function or the whole fraction is under the square root. So that needs to be positive or greater than or equal to 0. Now that looks like a mess, but once you multiply both sides by the denominator will cancel out and it'll leave you with 0 on the right. So you end up with x plus 2 times x minus 3 needs to be greater than or equal to 0. Now you can't simply solve this like the previous example because this is a quadratic. So the easiest thing to do here is to set each factor equal to 0. So this is going to give you x equals negative 2, and this will give you x equals 3. And we're going to set up intervals around those points. And that's because this would be a quadratic, or because it's not linear. The previous example was a linear term or a binomial. These would make a quadratic if you FOILed them. And you can't just say that x plus 2 is greater than 0 or x minus 3 is greater than 0. So we're going to test intervals around -2 and 3, and also our 1 from above. There is a hole right there. So we're going to have an interval from -infinity to -2. And we're going to have from -2 to 1. I'm going to put a parenthesis on 1 because it can't equal 1 or you have a problem. And then from 1 to 3, and then 3 to infinity. So I'm going to choose a point inside each of these intervals. So let's say -3 in the first one. I'm going to pick 0. Let's pick 2 and 5. And I'm going to test those back in this original inequality that I set up to see that if it's greater than or equal to 0. So let's test x equals -3. If you plug that in there, you're going to have -3 plus 2 times -3 minus 3 over -3 minus 1. And that's going to give me a -1 times a -6 over -4. So I'd have a +6 over -4, which reduces to -3 over 2. What I'm concerned about is the sign of this number. It needs to be greater than or equal to 0, and this one isn't. So that interval will not work in my domain. So now I'm going to move on to the next point, x equals 0, and plug that in for x. Here I've got 2 times a -3 over a -1 is going to give me -6 over -1, which gives me a +6. So that is greater than or equal to 0. So -2 to 1 will work. Checking 2. And like I said, this can be any point in that interval. I just picked these random points just as long as they're between the two numbers. So here I'm going to have 2 plus 2, 2 minus 3, and 2 minus 1. So that's going to give me 4 times a -1 over 1, which is a -4. That is not greater than or equal to 0, so that doesn't work. So let's test our last interval at x equals 5. So I've got 5 plus 2, 5 minus 3, and 5 minus 1. That's going to give me 7 times 2 over 4, which will be 14 over 4, which is a positive number, so that will also work. So my domain for this function is going to be -2 to 1, but not including 1, unioned with 3 to infinity. So that's the best way to check for your domain when you have a quadratic or higher. Okay, let's look at one more example. And again, this has a couple problem spots. First of all, the denominator cannot equal 0, so the entire thing on the bottom cannot equal 0. And then also, what's under the square root by itself has to be greater than or equal to 0. So on the left, I'm going to just go ahead and move this to the other side by adding it to both sides. So that'll leave me with 5 cannot equal the square root of 2x plus 7. So I've just added that whole thing to both sides to make it positive. And then to get rid of the square root, I'm going to square both sides. So that's going to give me 25 cannot equal 2x plus 7. And then subtract 7 from both sides. I get 18 cannot equal 2x. And then divide by 2 will give me x cannot equal 9. So that's one part of the domain. And then on this one, it's linear, so we can just solve it normally without testing the intervals. And I end up with x has to be greater than or equal to negative 7/2, or you could say negative 3.5. You can leave it as a fraction or turn it into the decimal. So here, if you look at the number line, and this always helps to visualize what's going on, you've got a hole at 9, and then this part says x is greater than or equal to negative 3.5, or 7/2. So you're going to have a closed, and it's going to be everything greater up until 9. It'll jump over 9 and then go to infinity. So you're going to have negative 3.5 up to 9 unioned with 9 to infinity will be the domain for that function.